Hi everybody, welcome to our second video on partial fractions. In this video, we're going to explore how to use the partial fractions method when we have in the denominator not just a linear factor with a different linear factor, but a linear factor that occurs more than once. So we want to use the same methodology. That is, we want to take the fraction and decompose it into a bunch of simpler fractions. But it's not going to be quite as easy. We can't just write x plus 2 and x plus 2 and x plus 2. Those would have a common denominator. You just shove them right back together. So the trick is going to be, if I want to take a fraction like this one, and I want to decompose it, I'm going to decompose it into as many fractions as this exponent here. The first one, I really will just use an x plus 2. The second one, however, I'm going to use an x plus 2 squared. The third one, I'm going to use an x plus 2 cubed. Okay, again, it's not obvious that this should work, but again, there's a theorem, and the theorem tells us I can find constants, a, b, and c, such that I can actually decompose the fraction on the left as a sum of the fractions on the right. And if I do it, I will get the same answer as when you do it. Okay, so there's a unique solution, A, B, C. Okay, from here, the solution method is going to be very, very similar. Okay, so I'm going to multiply through, again, by this denominator, x plus 2 cubed. And when I do that, again, it's going to cancel some of the denominators here. So x plus 2 cubed times the a over x plus 2, well, you'll still have an x plus 2 squared in the numerator. Okay, so moving over here, we're going to multiply by this denominator, and we get x squared plus 2x plus 4 equals a times, okay, we get rid of one of the x plus 2's, and we have x plus 2 squared. And then here we have b times, well, we get rid of two of the x plus 2's, so we have b times x plus 2. And here, well, when I multiply the x plus 2 cubed, all the x plus 2's go away, and so I'm left with plus c. Okay, now we're going to distribute. And now, the first one, we be very, very careful. X plus 2 quantity squared, not x squared plus 4. There is a middle term in there. You need an x squared plus 4x plus 4. Plus, again, we have b times x plus 2 plus c. Okay, let me find all my x squareds. Well, there's just the one. So I have a x squared. And now let me find my x's. Let's see. So there's an x and there's an x. So I have, let's see, 4a x's. And I have b x's. So in total, I have 4a plus b x's. And now my constants. So let's see, there's 4a, a 2b, and a c. So 4a plus 2b plus c. All right, now we're going to compare the coefficients. So in this polynomial, I have 1x squared, and over here I have ax squared. Well, the coefficients have to equal each other, so a has to equal 1. Sweet. Okay, now we compare the x coefficients. So I have a 2 on the left, and a 4a plus b on the right. So 2 has to equal 4a plus b. But we already know that a is equal to 1, so 4a is going to equal 4. So 4 plus b is 2, b has to be negative 2. And finally, we compare the constant term. We have 4. That has to equal 4a plus 2b plus c. But now I already know 4a, well, a is 1, so 4a is 4. And let's see, 2b, well, b is negative 2, so 2b is negative 4. Hey, 4 and negative 4, those go away, so c has to equal 4. Okay, so this allows us to go back and rewrite, instead of an a, we get a 1. Instead of a b, we get a negative 2. And instead of a c, we get a 4. And so our integral can now be rewritten, which by the way should have a dx. Our integral can be rewritten is the integral of 1 over x plus 2 minus 2 over x plus 2 squared plus 4 over x plus 2 cubed dx. Now, we're going to be able to find an antiderivative term by term. The first one we already know how to do, right? In the last video, we talked about what to do when you have 1 over something in the form ax plus b. You might think we can easily do these as well, and you'd be right, but for the wrong reason perhaps. You can't just use the trick we learned in the last video. In fact, time to cut away. Okay, so in the last video, we handled finding an antiderivative of 1 over ax plus b to the, well, first power. Here we're going to replace the first power with the nth power, where n is not equal to 1, since we already handled that case. We proceed just as before. We do a substitution. U equals ax plus b, du equals a dx, which we can rewrite as dx equals du over a. This allows us to rewrite our integral as 1 over a integral du over u to the n. Now I just have to use the power rule. If I use the power rule, I get negative 1 over a times 1 over n minus 1 times 1 over u to the n minus 1. And now I can replace u by ax plus b, and I end up with negative 1 over, and I'll combine these, a times n minus 1 times 1 over ax plus b to the n minus 1. All right. It's not such a great thing to memorize, but you need to learn the process because you're going to do this a lot, especially in the sections on partial fractions. All right. However, after you've done this quite a few times, you won't have to memorize this formula whatsoever. You'll just know it, okay? And it's actually a lot easier when we plug in numbers. Let's do a quick example. Say we wanted to find an antiderivative for 2x, 1 over 2x minus 3 to the 5th power, okay? So what the formula is telling us, first, there's a negative. Second, 1 over, and we need this coefficient. We need that 2. Times, well, this n minus 1. That just means drop this number by 1. So 2 times 4. Times 1 over, now I copy, 2x minus 3. And again, I just drop the exponent by 1 to a 4. That's really not so bad. Of course, constant of integration. Don't want to forget that. Okay, so shouldn't be that bad. If this is a 1, that's even easier. Then all you have to do is 1 over, drop this by 1, copy your function, drop the exponent by 1. Really not as bad as the formula would make it seem like. Okay, so back to the show. Okay, so from our work in the last video, we already know we can write an antiderivative of the first summand as natural log absolute value of x plus 2. But now for these two, we're going to use the work from this video. We realize, okay, first there's a minus 2, just ignore that for the moment, 1 over x plus 2 squared. So there's no a term to worry about here. All we have to do is write, let's see, well, we'll start with a minus 2, and we have times negative 1 over, okay, we have to add 1 to this 2 to become a 1. And then we have times 1 over x plus 2 to the first power. Okay, and for the second one, again, okay, we'll just copy the plus 4. Now we have a cube here, so this becomes times negative 1 over 2. We add 1 to the 3, times 1 over x plus 2 to the second power. Okay, and of course, we have our constant of integration. Little bits of simplification can be done along the way. I'll let you guys take care of all that.